Hello friends, back to my channel. Today we are going to learn about the transportation problem. Last time we have learned about assignment problem. So now we will go to transportation problem. Now the word transportation itself says carrying material or goods or raw from one place to other place. That means from source to destination. Now to carry products from source to destination, there incurred cost. That cost we call as transportation cost. Now in an industry or in an organization, the final price of any product includes the transportation cost, which increases the price of that product. So if we reduce or minimize the transportation cost, we would be able to reduce or minimize the price of the product. So minimization of transportation cost is a main objective of any organization. Now how to do that, which are the methods, that we will study in this transportation problem. Now to solve a transportation problem, a matrix is prepared. You can see over here, these are the sources, which says from where the raw material is required. For the source like F1, F2, F3, these are the destinations to which the material would be transported from F1 to W1, from F1 to W2, like this way till WN. We are not aware about how many other destinations. For each source there is a supply capacity, or you can say as supply or capacity. For each destination it will require some kind of demand. So for each destination there is demand D1, D2, Dn. For each sources there is supply S1, S2, Sm. So whichever is the source, it will have its capacity, that how much it can give, and each destination will have some part or some demand from the market, that is D. Now this C11 over here is nothing but cost of carrying products from source F1 to destination W1. Now for this particular cost incurred is C11. This would be in numbers. Now this kind of matrix would be given. This matrix is called as an transportation matrix. We need to solve this matrix with the objective of minimization of cost. Now to solve this, we should know whether it is balanced or imbalanced. Same as we did in assignment problem, the only difference is to balance this problem, the total of demand should be equal to the total of supply or capacity. If this total demand is equal to total supply, then we can say that the problem is balanced. Else we need to add a dummy source or a dummy destination with cost 0 and keep the demand or supply whichever is which we having a shortfall of. Then from this particular transportation problem, we first try to identify whether the solution is feasible or not. That is finding initial feasible solution. Now to find initial feasible solution, we need to allocate some units from supply to particular destination by reducing the supply and reducing the demand. So if source require 50 units, we can allot 50 units to destination W1, but if it is available in supply, then reduce it from the supply and also from the demand. This we need to do continuously till all the supply and all the demand becomes 0. Now to do that, we have 3 different methods. First method is called as northwest corner method. Second is least cost method. Third is Vogel's approximation method. In short, it is called as WAM method. Now how to check whether the solution is feasible or not? We need to check this by seeing whether the number of allocations number of units allocated to destinations is equal to m plus n minus 1, where this m is number of rows, n is number of columns minus 1. If there are 4 rows, 4 columns, that means 4 plus 4, 8 minus 1, 7 allocations should be done. And if 7 allocations are there, then we can say that the solution is feasible. Now after checking this feasible solution, next step is we can go for finding the optimal solution. Now to find the optimal solution, method used is called a stepping stone method or modified distribution method. In short, it is called as Modi method. So only this method gives you the optimum solution. So now we will study first how to solve or how to find initial feasible solution. In this first step or first method is called as northwest corner method. How to solve this northwest corner method? If a given matrix is there, from that given matrix we need to select the northwest corner cell first. Then allocate the maximum number of units, reduce its supply and demand, and then go on allocating the allocations till all the demand or supply get fully exhausted. Continue this. Now we will be more flexible if we see this northwest corner method by solving an example. Here is the given example. If you see, there are 4 sources, S1, S2, S3, S4, 3 destinations, D1, D2, D3. For each source the supply is 20, second one 50, third 30, fourth 25. And for each destination the demand is 40, second is 30, third is 55. If you add all this, the total is 125, that means n. So here supply total is 125, demand total is 125. That is the reason we can say that total demand equal to total supply. So problem is balanced. Now we can find the feasible solution. Now for feasible solution we have selected northwest corner method, that is NWCM. Now here we need to allocate some units out of this 20, 50, this 40 to this particular cells. Now there are about 3, 6, 9, 12 cells. Now how to allocate, from where to start, that is the question, and that is the reason this method it says northwest corner method. So northwest corner, out of this cell select that cell which is to the north, means top, to the west means this cell. So north is top row, that is S1. We have 3 cells. Again west, that is towards the left. So this is that cell where we can make the allocations. Now here we have selected the cell. Now how much to do allocation? Now destination D1 requires 40 units. Supply S1 has only 20 units. So as it has only 20 units, we can only allocate 20 over here. So we can allocate 20 over here. Now if we have allocated 20, so this 20 would be given, so it will become 0 because this 20 we have given to destination D1. Now demand of D1 was 40, we have already received 20, now it is having remaining only 20 is required. Now as source S1 cannot give anything to anyone because it already being 0, so we can cut this for the safe point that we did not need to allocate any units to S1. Now the remaining this 6, remaining 9 cells are there. Again repeat this process. Again north, this is the top. Again west, this is that cell. Now how much to allocate? Demand is required is 20, we have 50, so here we can allocate 20. Now if we allocate 20, this 20 will become 0, Again this 50 we have given 20, so this will become 30. Now if you see, destination D1 required 40. We have already given 20 and 20, 40. So here we can draw a line specifying that D1 has already received what it demanded. Now we have this 6 cells, 4, 1, 5, 2, 6, 7. Now again northwest, the top is 4 and 1, its west is this. So here we can do the allocation. How much? S2 can supply 30, D1 requires 30. So we can give 30, reduce this 30, reduce this 30. Both have become 0. Again cut this, cut S2. We are remaining with only 2 cells, that is 2 and 7. Northwest, ultimately it becomes the top cell here. Source 30. Destination requires 55. Even if it requires 55, but we can only give 30. So give this 30 over here. Given this will become 25. Now last remaining is this. It has 25 as source. Destination can have only 25. So this 25 is given. So this becomes 0. Clear? Now seeing this, just we need to write the allocations. That is called as allocations. We can write as, first allocation is S1 D1. It is for 3 units it's 20. Plus second allocation is S2 D1. Its cost is 2, units are 20. Plus second S2 D2, S2 D2, its cost is 4, units is 30, plus S3 D3, cost is 2, units is 30, plus S3 S4 D3, cost is 7, units is 25. Now what we need to do is multiply its cost by number of units. Because take an example, if 3 units are there, 3 is the cost of each unit, then what will the cost for 20 units? So it would become 60. Similarly, we need to put all this and add. So after calculating all the thing, we get the final answer as 455. So for this transportation problem, the total cost for transporting some units from source to some destinations, total cost is 455. But again we need to check whether this is feasible or not. Now as we count the number of allocations, this is 1, 2, 3, 4, 5. The number of allocations is 5. Now to be feasible we required m. This is 4 plus 3 minus 1. It becomes only 6. That means both are not equal. So we can say that solution is not feasible. So even the answer is 455, but the solution is not feasible. Here we can go for improvements, but the improvements are in Modi method. This is how you can stop over here by just saying the solution is not feasible. This is enough for solving a problem. Clear? So only when number of allocations is equal to m plus n minus 1, then we can say that solution is feasible. Else, if not, then clearly mention the solution is not feasible and stop over there. So next time we will study the next method, that is LCM. Hope everything is okay. Kindly subscribe my channel, click the bell icon. We'll be back with more videos of transportation and also the variations within it. Have a good day. Bye.